Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is inverse trigonometric functions. In this video we will be focusing on solution to previous year exam problems which have come in CBSE board exams. In the first problem we need to evaluate sine tan inverse tan 3 pi by 4. First we'll solve the term inside this bracket, that is tan inverse tan 3 by 4. We let y equal to tan inverse tan 3 pi by 4 where y belongs to minus pi by 2 to pi by 2. This is the principal value of tan inverse function. Then from this we can get tan y equal to tan 3 pi by 4 or y equal to 3 pi by 4. However, y equal to 3 pi by 4 is not the principal value since 3 pi by 4 is greater than pi by 2. So we can write tan 3 pi by 4 as tan pi minus pi by 4. Tan 180 minus theta is minus tan theta. So we can write tan y equal to, instead of tan 3 pi by 4, we write it as minus tan pi by 4 or y equal to minus pi by 4. So sine of, now this is sine of minus pi by 4 is minus sine theta, which is minus 1 by root 2. The given graph illustrates, a figure is given, a plot is given, and you need to identify it belongs to whether secant inverse, tan inverse, cot inverse or cosec inverse. Let us see the domain of this function, inverse trigonometric function. We see that it is containing all real values except between minus 1 and 1. And it is containing this side, and beyond 1 also it is containing this side. So domain is all real numbers minus the interval minus 1 to 1. It is written like this. And let us see why. Why the range is from 0 to pi. 0 to pi excluding pi by 2. This is excluding pi by 2. We see that the curve is not touching pi by 2. So it is excluding pi by 2. When domain is this and range is this, that function corresponds to y equal to sec inverse x. So A is the correct choice. Domain of f of x equal to cos inverse x plus sin x is, we know that the domain of cos inverse x is minus 1 to 1 and sin x domain is all real numbers denoted by r. Now when we take the function cos inverse x plus sin x, its domain will be intersection of r and minus 1 to 1, which is nothing but minus 1 to 1. Hence the solution is C. Study the given graph. It illustrates y equal to tan inverse x, y equal to sec inverse x, y equal to cos inverse x or y equal to sin inverse x. Let us see the domain of this function. Domain is the values taken by the function in the x direction. X direction means this side. That is minus 1 to 1. This function is taking values between minus 1 to 1. And the range is on the y-axis, which is minus pi by 2 to pi by 2. Both are inclusive. And this domain of minus 1 to 1 and y belonging to minus pi by 2 to plus pi by 2 corresponds to sine inverse x function. So option is D. The given graph illustrates, the figure is given, we need to find that it belongs to which inverse trigonometric functions. We see that the function takes value from minus infinity to infinity, so domain is R, all real numbers, and y is taking values from minus pi by 2 to plus pi by 2. Another important thing is that the function is passing through the origin or 0, 0 coordinate, and this corresponds to function y equal to tan inverse x. Here we see another function. We need to identify whether it is a trigonometric or inverse trigonometric function. Here one very simple and effective idea is that whenever you see on y-axis angles like this 2 pi, 3 pi by 2, it corresponds to inverse trigonometric functions. Immediately you can rule out y equal to sec n and y equal to cosec x. These are trigonometric function and not inverse trigonometric function. So immediately you cut off this. B and D not possible because on y-axis you see angles like 2 pi, 3 pi by 2. So this curve is a inverse trigonometric function. So it could be either y equal to sec inverse x or y equal to cosecant inverse. Now let us see the domain. Domain is again, it is minus infinity to plus infinity except between minus 1 and 1. So this is domain is our real numbers minus 1 to 1. And what is y? Y is between 0 to pi excluding pi by 2. Pi by 2 the curve is not touching pi by 2. This curve is not touching. So that is excluded. And we know that when domain is this and range is this, it corresponds to function y equal to sec inverse x. So A is the correct choice. We want to evaluate sec inverse minus root 2 minus tan inverse 1 by root 3. What we do, first we evaluate sec inverse minus root 2. Then second we will evaluate tan inverse 1 by root 3. So let us take y equal to sec inverse minus root 2, where y belongs to 0 to pi minus pi by 2, where for secant function this is the range. So this can be written as sec y equal to minus root 2. We know that sec pi by 4 equal to root 2. So sec pi minus pi by 4 will be minus sec pi by 4. Secant 180 minus theta is minus secant theta, which is minus root 2. So sec y can be written as sec 3 pi by 4. So y equal to 3 pi by 4 is the principal value and lies between this interval. Now we will evaluate tan inverse 1 by root 3. So y equal to, we let y equal to tan inverse 1 by root 3, where y belongs to minus pi by 2 to plus pi by 2. Tan y will be 1 over root 3, y equal to pi by 6. Now we take the full expression, replace the sec inverse minus root 2 by 3 pi by 4. This is minus pi by 6 equal to 7 pi by 12. D is the correct answer. We want to find the graph depicts which function, this one. Again we have two trigonometric functions and two inverse trigonometric functions. Clearly we see that on the y-axis we see angles. So whenever you see y-axis angles, you immediately ignore the trigonometric functions, and because when on the y-axis you have angles, it is an inverse trigonometric function. So we see domain of this function, or what is the x value is taken from minus infinity to infinity, that is all real numbers are, and y belongs to 0 to pi. Let us take this curve, and it belongs to function y equal to cot inverse x. Now this graph, the following graph is a combination of which trigonometric functions or inverse trigonometric function. We see that this particular function, this is nothing but y equal to sin x. This is y equal to sin x passing through the 0. Now a line is given as y equal to x, and we see that this curve is about the line y equal to x. We see symmetricity about this curve and this curve. They are perfectly symmetric. So this happens when we plot a trigonometric function and its inverse together, then it is behaving like this. So we know this is a sin x function, and since it is symmetric about y equal to x, this will be a inverse sin x function. So the correct answer is y equal to sin inverse x and y equal to sin x. The principal value of cot inverse minus 1 by root 3. Let y equal to cot inverse minus 1 by root 3, where y belongs to 0 to pi. This is the principal value range. Then cot y will be minus 1 by root 3. This can be written as cot pi minus pi by 3 equal to minus cot pi by 3 equal to minus 1 by root 3. So we can write cot y as cot 2 pi by 3. This is 3 pi minus pi is 2 pi by 3 equal to y equal to 2 pi by 3. Now domain of sin inverse 2x minus 3 is, we know that domain of sin inverse x, where x takes value between minus 1 to 1. Now we replace x by 2x square minus 3. So we replace here, add 3 in all 3 places. So this will be minus 1 plus 3. This will be 2x square minus 3 plus 3. This will be 3 plus 1. So this will be 2. This will be 2x square. This 3 will get cancelled. This will be 4. Now we divide by 2 throughout. So this will be 1, x square and 2. So let us put x square equal to 1, x will be plus minus 1. Similarly, x square equal to 2, x equal to plus minus root. Now we want to find in what region whether this is valid. X square less than or equal to 2 and greater than or equal to 1, which region it is valid. So let us take a number line here. We plot 0, 1, root 2. On the left side we say minus 1 minus root 2. Let us take any point between 0 and 1, say half. Let x equal to half and we put it here. So that will be half square, which is 1 by 4 is less than or equal to 2, that is true. But 1 by 4 is not greater than or equal to 1. So this region is neglected. We have put a cross here. Similarly, if you put minus half, this region will not be acceptable since this will not be satisfied. Let us take a point beyond 1 and between root 2, say 1.1. So 1.1 square is 1.21, which is less than or equal to 2, that is correct. And 1.21 is greater than 1, again that is true. So the region between 1 and root 2 is correct. Similarly, region between minus 1 and minus root 2 is correct. So the domain will be minus root 2 to minus 1 union 1 to root 2. Let sine inverse x by root 1 plus x square to be simplified. We put x equal to tan theta. Whenever you see root of 1 plus x square or 1 plus x square, the common substitution will be x equal to tan theta. So this will be sine inverse tan theta by root 1 plus tan square theta, which is sec square theta. Square root of sec square theta is sec theta. Tan theta is sine theta by cos theta. This is 1 by cos theta. So sine inverse sine theta. So which is theta, and theta is tan inverse x. So this function can be simplified to tan inverse x. We need to find the domain of sine inverse root of x minus 1. We know that domain of sine inverse x is minus 1 less than or x less than 1. X is between minus 1 and 1. Now instead of x we put root x minus 1. So we can write minus 1 less than or equal to root x minus 1 less than or equal to 1. But we know that for positive root this number will always be greater than or equal to 0. So we can write, instead of minus 1 less than or equal to, we can write 0 less than or equal to root x minus 1 less than or equal to 1. So squaring all sides, this will remain 0, this will become x minus 1, this will become 1. So adding 1 on all sides, 0 plus 1, x minus 1 plus 1 less than or equal to 1 plus 1. So this will become 1, 1 will get cancelled, it will be x less than or equal to 2. So x will belong to 1 and 1 comma 2 for sine inverse root x minus 1. This is the domain of x. The principal value of cos inverse x is, immediately we know that it is 0 to pi. So C is the correct answer. The principal value of sine inverse sine minus 10 pi by 3 is, we let y equal to sine inverse sine minus 10 pi by 3, where y belongs to minus pi by 2 to pi by 2. So this can be sine of minus theta is minus sine theta minus sine 10 pi by 3. 10 pi by 3 can be written as 3 pi plus pi by 3. What is sine 3 pi plus pi by 3? 3 pi will be, this is pi, this is 2 pi, then another pi is 3 pi. 3 pi plus pi by 3 will be in the third quadrant, where sine is negative. To sine 3 pi plus pi by 3 will be minus sine pi by 3. So this minus minus can get cancelled. This will be sine pi by 3. Sine inverse sine pi by 3 will be pi by 3, which is the solution. We need to solve cos inverse x plus cos inverse x by 2 plus root 3 minus 3x square by 2. We let x equal to cos theta. So cos inverse cos theta is theta. Cos inverse plus half cos theta. We are substituting x as cos theta. So this will be square root 3 minus 3 cos square theta by 2. This is half cos theta plus 3 into 1 minus cos square theta, which is sin square theta, which is sin theta. Root 3 will be out. So root 3 by 2 sin theta. This can be written as cos pi by 3 cos theta plus sin pi by 3 sin theta, which is nothing but cos pi by 3 minus theta, cos A minus B. Cos A minus B is cos A cos B minus sin A sin B. So cos inverse and cos will get cancelled. So we will remain theta plus pi by 3 minus theta. Theta will get cancelled. The final answer will be pi by 3. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.